All right, next up. Next up would be the domain of the function. Can anyone still tell what the meaning of the word domain is?
How far it goes is the x from least to the most?
I like the word x value. Okay, it's about x value from least to most. Good. The other way I would simplify the definition would be, what are the possible x values for that particular function? For example, okay, let me give you a more some example that you have seen from last year. If I have a quadratic function, okay, that goes all the way left and right, what will be the domain for this function? Everybody. All root numbers, right? Okay, so that's good. Now, what if I have a square root function? Okay, we learned about square root function last year. In that case, what would be the domain in this case? 0 or greater, right? Now, and also last year, we had, if you remember from last year, okay, we asked a bunch of questions about domains and range. And by the way, since we are talking about domains, may as well talk about range as well. What's range? The y value, the possible y value. So it's always about asking a question. Okay, when we ask, hey, what's a domain? That means, what is the x value? The range is, what is the y value? What are the possible x and y values for domain and range? Now, last year, we also did this thing called inequality expression. If you're in my class, you should know how to do interval notations. And in this course, we will do exclusively interval notation. So what I'm going to write down could be something new to you if you were not in my class last year. Now, okay, now let me ask you this. Can you make a quick sketch of this function on the blank space to the right? Can you? Just a little sketch. Yeah, there's some empty space to the left of it. So can you make a little quick sketch of it? Okay. What kind of line is this? Can you describe what this function is? Linear, right? How do you know it's a linear function? How do you know it is a linear function, but how do you know that it's a linear function? You can say that. Okay, parent function is y equals to x. That's a very good point. Any other suggestions? Yes.
It's to the first power.
It's to the first power. That's also very good. It's x to the first power. That's a linear function. Any other way that you can tell it is a linear function for sure? Now, if you're afraid to say it, that's okay. Does anyone have the term slope-intercept form in your mind? That this is mx plus b. The slope is what in this case? What's the slope? The slope is? Everybody? 1. Mx plus b, okay? Y is equal to mx plus b, okay? The slope is 1, the y-intercept is 3. So, so if you are making a sketch, it should look something like this. And the reason I'm asking you to make a quick sketch is because I guess most of you are taking the SAT or ACT, and I would tell you that you must know the 3 forms of linear equations. What are the 3 forms of linear equation? Now here, this is the slope-intercept form.
Point-slope.
Point-slope form is another one. Do you know how to write down the point-slope form? Now, there's a little story. And by the way, there's a little bonus for you. The bonus is this. Think about what you learned in the past. Learned, not studied, learned. What I hope you realize, I just realized this like maybe last year. Whenever you learned something, there's always a little story that goes with it. It could be a small story, but it could be a large story, big story. But whenever you learn something, let's say you learn about maybe a very special vocabulary, there's always a story. I can tell you the vocabulary that really made a huge impression in my life. Verbatim. You know the meaning of the word verbatim? Word for word. When I first learned it in class, I was like, is that a word? Verbatim? And then I heard my teacher saying it and my professor said it. I was like, oh yeah, it's a word, okay? There's always a reason. There's always a story. And now, what about the point slope form? There's a story for me, actually. And there's a story for you too, because you got scammed and you didn't know it. So let me ask you this. On your paper, can you write down at the top of the paper, can you write down the formula to calculate slope? Can you do that? How do you calculate slope? We say m is equal to what? I would bet that 90% of students, or maybe 100% of students know how to calculate slope. What's the slope equation? Numerator? y2 minus y1 over x2 minus x1. It is common that some students may confuse the numerator and denominator, and let's go ahead and clear this up once and for all. It's y2 minus y1 over x2 minus x1. If you know this, then you should know the point slope form. And my teacher did not tell me that, and I was very upset when I found out the relationship between them. What's the relationship? It turns out that if you multiply this whole denominator to the other side, and you just go ahead and change the y2 and x2 into just x and y, so you have y minus y1, it's equal to m x minus x1. That is your point slope form. So if you know how to calculate slope, you know the point slope form. And then next year in calculus, this is going to be very important. Okay, so don't lose them. So you have slope intercept form, point slope form. Do you know there's another form for a linear equation? Standard form, yes. Standard form is ax plus by equal to c, and SAT loves to feed you this form. You know why? Now, for me, I would say it gives you basically nothing. And they need you to, they want to see if you know how to change the standard form into some useful form, like slope intercept form. Can you solve for y? Okay, so if you're taking the SAT soon, I want you to know that please make sure that these are all under your radar because you're going to see them. I don't want you to panic. And whenever you see standard form on the SAT, change it. You change it regardless. Change it to slope intercept form. Keep that in mind. All right. So, again, x plus 3, it's a linear graph. So what is the domain in this case? We say all real numbers. And how do you express all real numbers in interval notation? Oops, sorry. We'll say parentheses, negative infinity to infinity. Parentheses means exclusive, not including. So we say from, so the notation interpretation is like this. It's from negative infinity, and not including negative infinity, since we don't know what infinity really is. Comma means to infinity, and then parentheses means, again, we end there, but not including infinity. So from negative infinity to infinity. That's how we say all real numbers. Okay, good. All right, so this is easy. And I'm going to put I forgot to put asterisk over here. Yeah, so for this one, a lot of people actually stumble on this one. A lot of people. I don't want you to stumble here. So now, what you would do in PreCal is that you would start making some really good relationships with functions. You know about functions. You know the behavior of the functions. Like you know about square root function from last year. What do we know about square root function? What is it like and what is it not like?
Negative.
Complete sentence.
Negative number?
Complete sentence. I know what you're saying, but I want you to present it in a complete sentence.
Oh, so I have no idea. Maybe imaginary.
No. You have the idea. I just want you to present it in a nice way, because if you just say negative numbers, people may not understand what you mean by negative numbers. Anybody want to try?
Oh, so you mean like the square root of everything has to be positive?
Ah, now it gets better. So we're saying that, hey, this x right here, remember how we defined the domain? It's all about possible x values. Well, what's possible for this x? Positive number, it's good. Is 0 good? 0 is also good, right? So what you want to say is actually that we don't want x to be negative numbers. Because what's the consequence of having a negative number underneath the square root? That would be imaginary. We want to keep it real. So we say, hey, this x right there must be greater than 0 or equal to 0, right? It could be 0. It could be bigger than 0, but not anything negative, not anything less than 0, okay? Yes?
You don't want it to divide by a negative number.
That's very good. That's my next question, actually. So now you take care of the square root. You're like, oh, wait, hold on. I smell something different. I smell something that we need to take care of. Let's be careful, okay? Let's walk carefully. We say, yeah, x has to be 0 or greater for the numerator because of the square root, okay? And then we say, hey, one more thing. Look at it's a fraction. And what do we not want as a fraction? We don't want 0 in the denominator. What's going to happen if you have a 0 in the denominator? Undefined, okay? Now, if you are really rusty, it's okay. We all understand, second day of school. But keep in mind, like if you want to validate this with a calculator, you can go ahead and say, 5 divided by 0, what would it be? And your calculator would say error or it's crazy. So you don't want the denominator to be 0. That means x cannot be what? If you do not want the denominator to be 0, then x cannot be, must not equal to 5. Must not equal to 5. If it equals to 5, the function is going to complain. So now you look at all the things together. We're like, oh, okay, so it cannot be negative for x. It cannot be 5. So what do we have here? We say, oh, so that means we are going to include 0. So from 0 to what? Now, let me tell you what people miss. I'm going to write down the wrong answer. Some students will write down this. This is wrong because this is missing the 5, okay? So how do we include the 5 in the whole interval notation? We'll say, oh, so it's everything from 0 to 5, not including 5. And then we go from 5 all the way to infinity. So again, parentheses are used when you are not including the values, and use bracket when you include the value. So we use bracket for 0 because 0, it's okay. We use parentheses for 5 because we do not want 5 to be included. So another way to express this, if you use a number line, so it's more like this. So we say, yeah, 0 all the way to 5, and there's an open circle, and then it keeps on going, put an arrow right there. So that's more of a number line analog for the interpretation of this interval notation. But we will, again, use exclusively interval notations to express our answers. All right.